Okay, and we should be live. We should not be clipping. It's Saturday, 8 p.m. local time here. Probably not a good time for anybody to join a stream, but well. Okay, so today we do the recap of my TS-50 recapping. I took a few pictures and I can walk you through, well, my experience. I don't think there's anybody in the chat. Let's have a look. Nope. Okay, what else? I can also show you my face. Here we go. Hi, guys. And maybe that also works. Aha, see, background removal. Yeah, the slideshow is already there, so I can, in theory, continue. So let's go to the next picture. Okay, well, you've already seen that. That was the picture from the first stream. And here we are at the CPU board of the TS-50. I basically took pictures of all the sides before and after recapping. And yeah, I can tell you how it went. Or okay, so what do we see here? Let me see. I think I should also have a whiteboard application here. Yep, that works. That was the cat going crazy. Yeah, so what do we see here? That's the famous coin cell battery that always needs replacing on the TS-50. I did not do this. That was already the previous owner. Maybe I should resolder that ground connection here at the bottom, but for the moment it seems to be working. And you can also see that here's the connection where usually you connect your TTL USB interface for cut control. And I think, yeah, maybe the owner had it soldered down here, some ground connection, and maybe it was glued here onto that chip. Because if you look closely, then that chip is, yeah, you don't even see the marking anymore. It's a bit knackered. Anyway, that's the only things I can complain about on this eBay purchase. It was basically in pretty good condition, so I was very lucky. I remember when I opened my TH78E mobile handset, that already had leaking SMD capacitors, and it was already looking nasty. So this one was quite fine. So what do? We take out those two screws. Oh, sorry, I can't speak Russian. I hope English is okay. Maybe the auto translate can catch it. Yeah, so usually there's some shielding can on there. I already took that off. Okay, and in the next picture, basically I removed it, and that was the yeah, status before recapping. So there's a number of SMD capacitors here. Let me mark them, but we already saw that in the first live stream. Here are a few. Did I miss any? 1, 2, 3, 4, 5. And a few through-hole capacitors as well. 1, 2, 3, 4. So that board is pretty easy to do. You just have to be careful with all the connectors and, you know, unscrew it. And I think this was the capacitor that I did in the live stream, or replaced in the live stream. And yeah, it was working quite well with the two soldering irons. So I basically did the whole recapping with two soldering irons, basically one in each hand. Heating the pins and then basically lifting it up. I mean, it's a bit unusual technique, but I thought it's the safest way, because with yeah, for example, here you have this connector here, and it's not a SMD connector, so it's definitely not soldered on with all the other SMD components. So maybe afterwards, after they did the SMD components, they populated the through-hole components, and you never know if those connectors can take the heat of a heat gun. I have a Atten rework station, so I can, of course, use a nozzle and set it to 400 degrees, and then definitely all the SMD components will come off, but I didn't want to risk it with the connectors, so I used the two soldering iron approach. So next picture, that was already the reworked board, because it already has the new capacitors in. So, and this is the other side, that's the RX-TX side, and as you can see, this was really the tricky bit. So I did not want to do this in a live stream because you have to concentrate. Let me get my image out of the way, then I can show you all the capacitors that needed replacing. So here you had two. I'm just marking them all because there's still all the cables in the way. So all those had to go and be replaced. Let's see, there's another one. And there's one you can't see behind some cables. And then here on top behind the cables, there's, I think, another 2 through hole and another 4 or 5 capacitors under this cable. You will see it in a second. What was wrong with the transceiver? It's old. It's from maybe 1980. And all those SMD capacitors have a tendency to leak. So there's the electrolyte in there, and the seals at the bottom go brittle, and then the acid runs out. And when that happens, then basically it can destroy the complete transceiver, because the acid can eat through those fine traces here. And once that has happened, you can basically no longer rescue it. So the idea is, replace them while there's no major damage. And I was very lucky here to pick the right time to do the refurb. If you look on the on YouTube and just Google for Kenwood TS-50, you will see a few really terrible examples where the acid has already chewed through the PCB, and it's I think TRX Lab Peter has a few videos like that. So I was lucky with that eBay purchase. Okay, next picture. Yeah, here you can see I've already taken it out and already removed a number of capacitors, and I've already replaced those two, because those two here on the top were the trickiest. So this one here and this one here. My cat's name is Amy, from Doctor Who, Amelia Pond, Amy. Right, so these two capacitors were really nasty, because you cannot really get in there with the soldering iron at all. So here's a connector, and here's another connector. And in the end, what I did was I took that voltage regulator out, even though there's nothing to do, but it gave me the necessary space to get in with the soldering iron. So basically, I also taped those connectors with Kapton tape, which is a heat-resistant tape. I don't know, maybe it's just psychological, but in theory, you can protect surrounding components if you go and get a good quality Kapton tape. So this one was taken out briefly, and then I could basically use one soldering iron there and the other one from this side. Of course, angle it so that it doesn't touch that connector. And the other one I was already thinking about, do I have to take this transistor or voltage regulator out as well? But after I've taken that one out, I could get in with the soldering iron from this side and the other one from that side. So that was also doable. And the whole array here on this side, on the left side, was not as difficult as you think, because as you just have to how should I say, you have to take them out and put them in the right order. So you first take the through holes out, and that gives you enough room so that you can take the SMD capacitors next to them out. And well, when you put them back in, you go in the opposite order. So that was not so hard. Hi, Bobby. Thanks for joining. Yeah, right. This is what I was just saying to our Russian friend here. I can't read the Cyrillic name, but yeah, I know the true SDX or micro SDX. What else was I missing? Yeah, I think it's only eight bands. Well, it was all bands that were available to amateurs at the time. I don't think 30 and 60 meters were already available at that time. Okay, next picture. Here you can see I've already made progress. So the whole side here with those capacitors here and here is already repopulated, and yeah, well, the remaining are still to do. I bought a capacitor kit from eBay from some reseller, from some seller in the UK. It was basically very nicely packaged, very well labeled. Only for, I think, 2 through-hole capacitors, the footprint was a bit wrong. I think this one was a bit too big, so I had to angle the leads on the bottom. So usually you'd go like this through the PCB, and I think for that one I had to basically cheat a bit so that it fits. And that one on the top was also a bit of a tight fit. I don't know, maybe I think for all the capacitors the next higher voltage was chosen. So by default, I don't know, there were like 10 volts or 16 volts. This capacitor pack that I got, for most of those you can go to the next higher voltage rating and still get the same footprint, but those 2 through holes were a bit, didn't fit so well. Yeah, I don't have a lot of viewers. I also don't have a very successful YouTube channel. It's just for fun, you know. Right. Okay. Next picture. Everything is back, mounted back into the transceiver. So I was sweating a bit, and I did this offline without filming it. But it went fairly well, and I was also very lucky that none of those capacitors had already leaked. So I caught them before they could catch do any damage. But at the end, a few pictures from now, I can show you the ESR, and especially the small, tiny capacitors. They were really bad. Like the 1 and 10 microfarad capacitors, they had like 20 or 30 ohm ESR, so completely dried out. But luckily, dried out before leaking. So. Okay, next picture is on the front side. That was basically the TX and RX board and the PLL board. And now we go to the PA stage. And I initially made the mistake and basically took the connector out, but you don't really, the antenna connector out, you don't really need to do that. You just have to open these 4 screws on the side, and of course disconnect the coax cables, and then press here the ATU connector in, and then you can take the complete low pass filter board out. It's only low pass filter, Bobby, I think. For the TS-50, there was this there was a separate tuner sold. It was called AT50. I still have to get one of those. Then I have the set complete. So that's just relays and low pass filter. But yeah, you basically can take it out by just unscrewing 4 screws. Anyway, I also took that one out and inspected it from the bottom and then put it back together, but that was a mistake. Okay, and then when you take this off, you get down to the amplifier section. There are no more SMD capacitors in that area. Everything is through hole. So let me mark it again. Yeah, 100 watts output power. So here you have 2 big capacitors, and then you can't really see it. They're small. There's 4 small, I think 10 microfarad or so between some power regulators here. Here are 2 through holes, and there is one, and there is one. So that was, from a soldering point of view, doable. You just have to be careful, take the connectors out and make sure that the right connector goes back into the right location at the end. For example, I had marked this cable with an extra dot here. You can see these 2 black dots because 1 level down you have another cable coming here. Or so I thought, but then I realized that this is non-removable. So I marked it before I took the board out. But this one is basically, this is the driver stage. So here comes the, non-amplified output frequency, and then goes into the amplifier. Transistors at the output. I guess you can see it. It's a Toshiba 2SC2879. And I don't think they are very cheap. So when you fry them, then you have to think about. And they're also very robust. I think I saw people on some internet forum boasting that they could get up to 180 watt out of the Kenwood. I'm not sure why you want to. But it's good that this thing is very robust built. What else do I have to say about this one? When you take the PA board out, there's one transistor which is isolated. This is this one. So there's a little plastic grommet under the screw, and on the back side there's a little mica isolator. And of course, when you take it out and clean it up and put it back in, you have to make sure that you isolate that one again, otherwise it's dead. Okay. Hi Andy, thanks for joining. I wanted to make you moderator for this chat if I find out where. Let me see. Can I just right click somewhere? Did that work, Andy? I think so. Okay. Next one. Okay, I took it out, and of course everything is full of thermal paste, so you have to really give it a good scrub with isopropyl alcohol, IPA. I think I pronounced it wrong. You know what I mean. Clean it up with alcohol. And then I don't know if you can see it, but maybe it's on purpose, but a few of the coils that you see on the top side, like the small coil here in the middle, they soldered it in and they kept the legs pretty long. And I think on the I can't see it, but I think on the I don't see it on this photo, but somewhere here there were some long legs sticking out from some coil, and it was almost touching some other connector. So I cut them a little, but maybe it was intentional. Maybe the idea was that even if it heats up so badly that the solder liquefies, that the components don't fall out. Maybe that was the thinking behind it. Why did I take out the PA? Well, there were also capacitors on there, and I thought I'll do them all. Even though they are through holes, they probably would have still lasted a while. The through-hole capacitors were not as bad as the SMD ones. But, well, I got the complete kit, and it had all the SMD capacitors and also the through-hole ones. So I thought, okay, when I do it completely. Okay, so that's the top side. And another interesting thing, which I don't know if there was anything wrong with it, but I saw that this is some, I think some thermistor for controlling the fan. I think this, if you look at the back side, you see here that here there's a bit of SMD stuff going on, and I think the whole purpose of this section is really to say measure the temperature and find out when the cooling fan has to be switched on. So and when I took it out, I realized that thermistor was not really making contact to the PCB. I mean, there was thermal paste. Sorry, I said it wrong. It was not making contact to the heatsink. So when I took it out, I saw that it was not soldered in like it's supposed to be. Let me try to draw it. So here you have if this is the side view of the PCB, I think how it's supposed to look like is like this. That it goes down here, and then here you have the connection leads, and here you have the screw. And on the next picture you will see here is the contact point, the contact point for the thermistor, and yeah, it basically was soldered in a way that it didn't make contact. So the leads were too long, and it was basically at an angle. I mean, I'm just exaggerating right now, but it was basically, it was like this. Yeah. And yeah, there was the counterpoint, and it didn't really make contact. Yeah, which probably meant that it took a while until the fan was switched on. So in the end, I just desoldered it and put it in a way that it has contact to the heatsink. And I tried it because I didn't even know if the fan was working. So I transmitted for key down for, I don't know, maybe 2 or 3 minutes into the dummy load, and then the fan came on. So I think it's good now. Okay, and that is I think already one of the last pictures, and that's getting the thermal grease on. I think that was how should I say, the job with the least fun. Okay, it was all over. My fingerprints were all over it because it was not really possible. I mean, the thermal compound that I had was pretty thick. It was from when I built my desktop PC, and it really does not flow at all. So usually the rule of thumb is as thin as possible, but it should still cover everything, right? And if it's if the viscosity of the thermal compound is pretty high, or I mean, this was I think it was thermal grizzly cryonaut, and it's very thick and it only flows when pressure is applied. Yeah, so you cannot spread it with a credit card, you cannot spread it with a brush. You can just dab it on somehow, and then I don't know. I've done a very bad job, hence the crying tears here. So, well, anyway, I hope when I screwed in the PCB again, it flowed, and I did not create a disaster in the making with the 2 power transistors here. So, but that was really no fun at all. Yeah. So, but I also didn't know what thermal compound to use. Yeah. So I used what I had, and I also got what was it? Arctic Silver MX6, but it only arrived like 3 days ago. So I thought initially maybe I should use that. Important bit is you should not use any liquid metal stuff. Yeah. Use non-conductive thermal compound. Okay, I think, that was already it. So in the end, I had a box of capacitors, and I can tell you that the ones on the right side were the ones that tested okay. And the ones on the left side were the ones that tested bad. Okay, it's maybe not really clear for every single capacitor, especially for the small ones. I can guarantee you the 1 micro or 10 microfarad capacitors, they were really terrible, and there's nothing to argue about that they had to go. For the others, it's hard to know now if they were low ESR in the first place, probably not. And then if you go today in the year 2023 and check out the manufacturer's web page, like Elna for the through-hole capacitors, and I think the other ones were Nippon Chemicon SMD capacitors. You find, of course, on their webpage big tables, but you don't find a table that tells you the capacitor that was manufactured like 40 years ago had that expected ESR. So I basically decided for myself everything that has a smaller 1 ohm is good, and everything which has higher than maybe 2 or 3 ohms is bad. And the one in the middle is a gray zone, and I'm no expert, but we are talking about 30 years old, 40 years old capacitors, so they won't get better. So anyway, they all were replaced. And in the next picture, I went through the exercise and measured every single capacitor that I've taken out with the Peak Atlas ESR meter. So I don't know if you can read that. Let's see, I should also be able to go to the monitor like this. And then I can zoom in. Yeah, that should work. So here on the right side, I had all the SMD capacitors tested. So all the 10 microfarad ones were around 3.4 to 5.2 ohms. I mean, I've looked at the Nippon Chemicon webpage and just said, okay, for SMD capacitors, 47 microfarad, 16 volt, what was the worst case ESR that they claim? Yeah, and I mean, it was a bit of guesswork, but I think when they say worst case 2.2 and we're already at 3.4 or 4.4, then we should take them out. Then here was one 47 microfarad, 16 volt, 2.4 ohm. Okay, maybe on the edge. So yeah, and here as I said, the small ones, the 10 microfarad ones, they're really terrible. Yeah, I think the worst case that I found on the web page was 3 ohms, and here you can see 12.5, 13, 11.6. I mean, there's absolutely no doubt that those are bad. Again, 22 microfarad, 5.4 ohm, 5.5, 5.5, they have to go. And 47 microfarad, 4.5 ohm also had to go. So, yeah, I think the lucky occasion here is that I could take them out before they caused any damage on the PCB. And on the left side, I have the LNAS, and there it's not as clear, because I could not really find information for like 40 years old LNA capacitors. But okay, they're also probably not low ESR in the first place, so maybe they're still okay. But yeah, I basically measured them all, and those which were below 1 ohm, I put in the still okay bucket. And the other ones which are close to 1 ohm or above, I put in the bad bucket. But yeah, are they really bad? Maybe not, but they're definitely old. Okay, so that was more or less everything I had. How long is the stream running? Not too bad this time. Usually I keep rambling for hours. So let's go back to the slideshow. Yeah, give it to me, please. Yeah, of course, everybody wants a refurbished Kenwood. I want one as well. So I wanted that radio since I was a teenager. That was the radio I wanted when I made my my big license, yeah. But of course I couldn't afford it at the time. And now it's here. I could still do a few more things to it, like take out off the knobs and give them a good scrub. And then maybe, I don't know if it makes sense to put in a temperature controlled crystal oscillator. What I've did after I've refurbished it, let me scroll back to the PLL board. Basically used my GPS disciplined oscillator, put it on one channel on the oscilloscope, 20 megahertz, and then connected the second channel of the oscilloscope to the test point here, and then here is the trimmer where you can get it on frequency. Yeah, as you can see, here is an option to put in TCXO, which gives it better frequency stability. So I think there's some ham that sells a replacement board. You cannot get the original SO2 module from Kenwood anymore, and if you can, then you pay like $400. So I think, yeah, maybe I'll spend, I don't know what is the replacement. I think it's called SO2-NG or so, and you get it for, I don't know, $50-60. I can't remember, and it has a 0.28 ppm. Oops, this is not really good for writing. Okay, that was the whiteboard up. Let's forget it. Yeah, you can get a 0.28 ppm TCXO in there, and another thing, maybe I'll put again back a USB to TTL interface as cut control. And then as a third hardware mod that is possible is you can get a small hardware board so that you can connect a RTL SDR or something to it. Then you can do your waterfall display like the IC 7300. But on the other hand, I really like it. I've used it now that I've refurbished it, made a few contacts for the WRTC award. Well, how's it called? It's not the contest, it's the promotion for the contest, right? So I made a number of contacts with that already, and it's really working well. I think it might work better than my FTDX 3000, transmit-wise. Receive-wise, of course, I don't know. The noise blanker doesn't seem to do anything for me. I don't know if that is normal or if it's broken. Noise blanker doesn't seem to have any effect. Apart from that, it's really it's nice because you can learn it and you don't have to. I think the limited amount of options is sometimes a good thing. I think I even managed this morning to do my first split QSO because it works exactly as you would expect. You set your two VFOs to the frequencies and push the split button, and then you can, as soon as you transmit, it uses the non-active VFO, I think, for transmitting. I mean, it's all simple, straightforward. It's really, really nice. Let me look what the guys in the chat say. Yes, I MRX79. Yeah, I really like the Kenwood look. I still think it's and also like if you invest more money like TS890, 990, yeah, they just look gorgeous. Yeah. On the other hand, I must also say I love the digital noise reduction of the Yaesu, so the FTDX 3000. It's, you have all kinds of noise on the band and you press the button and then the noise fades into the background and you have almost radio quality. So, yeah. That's why you need more than one radio, because they're all nice. Regarding micro SDX, I would just try to buy, it depends if you want to build it yourself or not. But I think if you're not soldering expert or so, then it's maybe the best thing would be to buy a true SDX from Sunny. So you go to the homepage from Manuel and look up. Let's just do it. Let me see. Can I close that? And then there's all kinds of shit here on my monitor. And then I need a browser window. Let's look it up quickly. Where is the... Here we have the True STX web page, and where are the suppliers here? Where to buy? Don't buy black nanorig. Here, official suppliers, tested and approved. Try one of those. And also here's an eBay store. So this is what I would do. That is probably the cheapest way to get a HF radio. Yeah, and maybe, I don't know, if you're not into kit building yourself, then get it readily built. That would be my suggestion. Okay, then I would say 45-minute stream. And don't make it so long today. Shall we end it? Are there any more questions? So how long did it take me to do this? I think I did it, yeah, I think over three days I did it. But if you do not go for a you know, kit where everything is nicely labeled like this one, then it should probably spend another 3 or 4 days in searching all the parts and try figuring out what footprint each bloody SMD capacitor has. So that will take a big part of time as well. So yeah, but it worked fairly well, I must say. I'm happy that I didn't break it. And yeah, let's see. Maybe I also have a magnetic loop here since a year that I have not really used out in the field. So maybe that would be the a good combination. You know, take the TS-50, set it to 50 watt, and together with the magnetic loop, go on some open field and make some contacts. This is maybe something I should do. Okay, so yeah, maybe it was not as interesting as the first live stream, but yeah, I hope you understand that I didn't want to ruin the radio live and in color. So if anybody wants these pictures, you can send me an email. You can find me on qrz.com, DL3MHT. Okay, so thanks for joining, and let's see what we do next time. I still have the FDK Multi 2000 where I made a video that also has lots of capacitors, but maybe I should do some interim project. I have to get one of those chunky Farad cores that Colin is using. I've created now a DigiKey account, but you can order them, but it's like, I don't know how many weeks lead time. So yeah, definitely more end-fed half-wave experiments coming. I have one failed experiment still on my bench where I managed to fit a FT140-43 inside a FT240-43 with a bit of filing. they fit inside each other, and then I wound the end-fed half-wave transformer, but unfortunately the result is it didn't work. So maybe I can make a YouTube Shorts video out of that. There's probably not much use in spending time on a failed attempt. Okay. Then thanks, Andy, for joining. Thanks to our Russian friend, and to Ben, and to Bobby. And until next time. Bye, guys. 73.